Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com. And thank you, Michael, for the pre-roll and the design of all these great graphics that I would never be able to do. This is, as the man said, or didn't say, VUC 565. I have a terrible echo of myself in my headset, so I may sound like a moron. But then that may not change anything. I don't know. Anyway, I'm going to show myself before we welcome our guest. I just need to find the camera. There we go. Hey, it's me, 565. We have a great crowd as always. We've got Andy Smith, James Bodie, Michael Graves, Tim Panton, and of course our guest who is Ben Ward. I'm going to show Ben. Welcome. Thank you for joining us today.
Hi. Thanks for inviting me.
We're glad to have you. Ben, I warned you about this. We have a tradition here, which is to ask people how they even got into technology in the first place, and then lead us up to Flood Network, and that way we'll be able to talk about Flood Network.
Wow, okay. I have to cast my mind back a bit. That makes me feel old as well. I thought I was one of the younger ones, but it's funny how it creeps up on you. I think I got into technology through the ZX81, or the Sinclair Spectrum. My uncle had one. I thought it was the coolest thing since sliced bread, and I had to get involved in it. And then when I went through school looking at vintage computer graphics, so when Pixar was really just starting, things like rendering digital elevation maps into a flyby of Los Angeles for NASA. I actually went and found that video recently, and I could recreate it in Google Earth live, which pretty much that was pretty shocking for me, that something that would take 3 weeks to render was now something I could do live on my computer. In '93, I discovered the internet, and I said, this is what I want to do. And well, I became telecoms somehow. I don't know. I hated those guys. I thought I was cool on the internet. So yeah, here I am.
All right, so Flood Network, by the way, Tim, thank you, Tim, for suggesting Ben as a guest. Flood Network, Oxford is an example of, that's an iteration of the Flood Network technology, right?
Yeah, Oxford Flood Network has now become a sub-project of Flood Network. So we actually launched a startup this year. It got some seed funding from Bethnal Green Ventures, to social tech seed funds, and also Ordnance Survey, which is the UK's mapping agency. So we're developing the technology from a community sensor network into something that could potentially disrupt the way that flooding is monitored. So yeah, if I can do a little bit of introduction to it. I've actually got...
Before we start, I should also say that there is a URL people can go to while you're speaking, which is co.uk. Go ahead, Ben, and explain to us what exactly the Flood Network is doing and how it works.
Alternatively, you can send them to flood.network.
Flood.network.
Flood.network will get you there quicker, unless you're using an old DNS lookup, and then some of the email doesn't always arrive because people don't keep up with new top-level domains, it seems. So let me just show you a couple of things from. Let me just put a couple of slides on. and then I can tell you about what we do. So I'll share that. So this is Oxford. This is what happens when some of the rivers flood. This one's actually not even the main river. So the Thames runs through Oxford. This is a couple of miles from the Thames, and things like this can happen all the time. This was actually in the summer, so this isn't even a winter flood. Because that information is quite difficult to get hold of, the Environment Agency only provide a few places where it can be monitored. These kind of things really catch out the authorities. So this here is actually a map of the existing monitoring network. That's the Environment Agency is a government-funded organisation that monitors water levels, flows, and many other things to do with water quality and but also the natural environment. So they do a lot of things. This is their monitoring network. I think there's 5,000 stations around the country. But if you zoom in, what you find is that it's actually fairly sparsely covered. So those are the monitoring stations in Oxford that already existed before we started. And the road that picture was of isn't even covered by those. There is nothing there that would help you know that there was a flood there. Now, I live in Oxford. I stupidly bought a house in a floodplain, and I decided, well, you know, I'm doing Internet of Things conferences every week here. They keep saying the Internet of Things will change everything. This will be incredible. There'll be 50 billion devices on the Internet by 2020. But no one was making anything. So I just thought, well, why don't we make something? So there's a flood risk area. I'm pretty much where that green dot is in the middle. That's where I live. So I thought I could probably do something to apply Internet of Things technology to this. Now this is the existing equipment. You can see they've dug up the side of a river. There's a riverbank there. There's some sandbags. There's a stilling well. There's a big telemetry box. They love their big green boxes. And inside there's probably a GSM system, some GPRS modem. That's our sensor. That's somewhat smaller and easier to install. So we don't know for certain. We think it's around an order of magnitude cheaper to install and buy and run. And these devices use ultrasonic sensors to detect the surface of the water and measure the distance to the surface of the water. If you subtract that from the distance to the riverbed, you get the height of the water. It's fairly simple technology. There's an antenna on there which transmits back the readings to somebody's broadband nearby, so it becomes a community effort because it needs to collect data over a short range. We're working on a medium to long range one, which will be using LoRaWAN technology, and we have a commercial one which uses GSM and GPRS, but it's definitely not the size of this thing. It's more the size of a slightly smaller thing, slightly bigger than this, somewhere in between, let's say. This is our first sensor that we installed. As you can see, you can't see it, and that's the whole point. So it was actually what we coined guerrilla sensor network, in that if nobody knew it was there and nobody knew you were doing it, could you get away with it? And if no one knew you were monitoring things, actually what could you do? You know, could you monitor air quality? Could you gather evidence about speeding or pollution or noise or flooding and use it as evidence for your own agenda? So it's interesting for community groups. Now, community groups aren't known for having a lot of money, and I had to had to find a business model for this. So we moved towards local authorities using the data to actually understand the situation on the ground, to put out flood barriers, to put out sandbags, and close roads, because that kind of observation information just isn't available to them at the moment through the national agency, and they can't really afford to put in lots of expensive sensors themselves. That's the location of our second one. That one hasn't been installed yet in this picture. Now this is the way to look at it if you're looking at where the data comes from, whether you trust it. So the Environment Agency is the lowest resolution data, so it's very sparse sensors. It's spatially quite low res. The crowdsourced data, which is the stuff that we use people's broadbands for, that's much higher resolution. You can put them in ditches, you can put them under floorboards at the end of people's gardens, in ditches which are normally dry. You can actually see where the water's coming from. Unfortunately, it's not very trustworthy, because can you trust the data coming from people's back gardens? Have they looked after it properly? Has a spider moved into it? Is there a duck floating by underneath it? We actually have duck removal algorithms, so don't worry about that. But the trust levels are much higher in the Environment Agency's data and lower on the crowdsourced data, but inversely the resolution is lower. So I think there's a good way to overlap those and actually combine them, as long as you can show the origin of that data, and then use the crowdsourced data to actually add to the bigger picture. So an example of how this might work, this is the Met Office, this is our National Weather Agency. This is a system called WOW, Weather Observations website, and it's essentially crowdsourced. It's from people's weather stations. You can see the temperature there is all fairly standard, 6 degrees, 5 degrees, 4 degrees. You know, it's fairly easy to spot. There's one that's slightly cooler down there, that's 3.2 degrees, but you know, they all look like they roughly follow what they're doing. This is rainfall. Now, down in West Wittering near Portsmouth there, either there's a very, very localized torrential rainpour, or someone's sensor's gone wrong. So you can see it's actually fairly easy to spot if something has gone awry in the hardware or the in the monitoring. So it's not as daft as it might sound, putting in third-party crowdsourced data into actual observations, as long as you know where it all came from and you can remove it if you have any doubt. So the more readings you get, the less impact a single mistake can make. Now, the other thing that happens with crowdsourced sensors is theft. That's me demonstrating theft. Obviously, I've got some of these are actually screwed down, some of them have been stuck, some of them we used to use magnets, but I think that interfered with the radio. There's some interesting things to do with permissions and whether you should be doing it. Our first sensor, first sensor there looks like a bomb. It's not a good thing to be sticking under a bridge. It's something that looks a lot like a bomb. So we developed the hardware after that. Part of the inspiration actually came from the Safecast radiation monitoring network in Fukushima in Japan. So the government weren't giving enough information about the radiation levels in the evacuated areas in the exclusion zone, and so people just went out and installed Geiger counters attached to the internet and then crowdsourced the data and produced this, which is a heat map of radiation. That was pretty inspiring for me. We don't have nearly as much problem, you know, it's just flooding. It has its own problems, you know. Being flooded, I wouldn't take lightly, but certainly not like radiation. So yeah, that's how we've done it. We've had some help along the way from Nominets, who traditionally you'd expect to be doing running the UK's domain name system, but their innovation team look at things from Future Internet. Thing Innovations is a colleague of mine called Andrew, and he's made the hardware. And Warwick University are involved in. They have a PhD program that's studying the data from it, and that's the end result. What you get is a flood map. So down the left-hand side, you can see the graphs, the hydrographs, and they tell you what the water levels are. This is January 18th this year, so it's not January 2018. Don't worry, it's not predicting the future. And you can see the segments of river that are affected by the particular sensors. I could even show you in a minute an actual live map. But this is the kind of level of detail that you can get down to. Just a little stream that branches off in the middle of the city. That's that location I showed you earlier, and that shows you how much detail you can get. This is the exciting bit for everyone. This is the technology bit. I've got down there the progression of the prototype from the bomb-like one at the left. IP55 case with Sugru attached. I don't know who's used Sugru. Hands up, anyone if they've used Sugru.
I'm an investor.
You're an investor. Brilliant. Okay, so it's useful stuff just to bodge something together and make it work. The next one is mechanically fixed to the box, but they are all still IP55 up to this point, so they let water in. And what's the one thing you don't want to do during floods? Is let water in. So we went IP67, we designed the board for the case. We tried to figure out how to mount something externally while still attaching to the board and having a screw mechanism. It's a nightmare. Don't make hardware if you don't have to. Buy someone else's hardware or get them to compete with you, and then they'll make it cheaper and then you can buy it. Just don't waste your time making hardware. It's really difficult and time consuming, and when you've made 10 of them, you put 10 of them out and you find a problem with them, you've got 10 things with a problem out there that you can't fix, or you've got to go out in the cold and wet to fix. Slightly tangentially, but a key part of the project is the picture on the right is a TV white space radio. So that's a piece of hardware made by a company called Adaptrum from California. This is using the television UHF spectrum. It's dynamic spectrum access, which is a new way of accessing or allowing people to use spectrum. So instead of sending well, you probably don't send faxes these days, but you know, Ofcom and FCC, I'm fairly sure, do have a fax machine. You arrange some meetings, you go down to Southwark Bridge, you go and sit in a hot room and listen to people talk about coexistence and things like that. And eventually, after an auction and spending all of your cash that you don't have, you get some spectrum. Or with dynamic spectrum access, you use an API, you make a request and you get some spectrum. So I don't think you could get many orders of magnitude quicker than the other method. And I think being able to request a slice of spectrum from a database is absolutely game-changing. I can't say it will change the game because I know mobile operators exist, so they will probably try and stop this. They'll find a reason why not to. We've spent the last couple of years talking to Ofcom in the old style, and January 2016 looks like when it's going to be made available in the UK outside of a trial license. It's usable in the US and Canada, Singapore, the Philippines, and there are trials in sub-Saharan Africa and Brazil and quite a few other countries that I can't name right now. But yeah, it's picking up, but I don't think it's picked up quick enough to be immediately useful. So we've used it for backhaul. As you can see, the boxes are fairly big there. So there's no ASICs for this yet. There is a company in India that is working on an ASIC for 802.22, which is the long-range version.
Okay, Ben, if you... Oh, I was just going to ask you to show yourself if you have more slides.
Yeah, sure. So there's some contact details if you need them. This is what I should have underneath my face, if you see, but I used Chrome like a fool, so I can't get the banner underneath my face.
That is unfortunate. I
that
know
may help.
Mr. Bodie has a question, so I'm going to call on him as soon as he's unmuted.
Yeah,
James.
there we are, unmuted. Hi, Ben. What sort of volume of data are you moving between your sensors and your central point?
Every 15 minutes we send, I think it's 4 12-byte messages.
So tiny amounts.
Tiny amounts of data. They're traveling over the ISM bands. They've got to fight their way through that, and they're using radios which are essentially used for heart monitors. So it has to be very simple, very quick.
And so these are a LoRaWAN devices.
We'd love to have LoRaWAN. We don't have LoRaWAN yet. We have Sisico. They're based on, I think, Dallas or Texas Instruments radio.
Right. Okay. So
Did you mention how many sensors there are? If you did, I missed it.
No, I didn't. There's 15 in varying states of decay because weather and let's see, and theft and other things. So around the city at the moment, you can see there's quite a few there. There appears to be a flood because the Environment Agency may have changed their baseline, which means that our offset is now wrong. And this one is aforementioned hardware problem. We have the code in development to actually remove these spikes, which are known bad readings. But that's something that we can easily remove. It's a lot harder to actually fix the hardware first. So fix it in software, then go and replace the hardware.
did you mention what you do for power?
So no, I didn't. They're battery powered. So if I stop sharing my screen again, and I'll show you. There's a device.
Which looks a bit like a satellite rocket motor, actually.
Yes, it does look a lot like retro rockets and thrusters, and we use one AA battery. It's actually a specialist one that's 3.6 volts, and that lasts about a year.
That's pretty good.
Yeah, I think we could do better, and if we had solar, we could last indefinitely. Although there's a lot of trees near rivers, lots of wet trees near rivers. That's also bad for radio. There's a lot of challenges with it, definitely.
So what do you do when the water level rises? Do you put your wellies on?
Me personally, I do to go and look at the sensors. But when the water level rises, what you can do is you can infer from previous experience where there were problems when the water reached that level. So you could be at the end of the road. You'd know that that path is submerged. You know that's fine for you. You've probably got another 20 centimeters to go before you have to worry, for example.
It's not as if you can do things like opening lock gates and move the problem downstream or something like that.
Yeah, you could definitely put actuators into the equation. That's managed by the Environment Agency, and they actually do manually do that. So they manually manage the river flow. So further downstream, Abingdon gets the results of whatever they do. So they have to be wary of Abingdon and upsetting them too.
Well, I suppose you can always warn them. Abingdon, there's 10 million gallons of water, 10 million tons of water on its way downstream to you now.
Yes, and then evacuate.
Put their wellies on.
A lot of it is to do with keeping the water safely stored somewhere without flooding anyone, rather than dredging everything and trying to shoot it through as quick as possible, because that's what's got us into this state in the first place. Upstream in the catchments, you've actually got very limited woodland, which means the water actually runs off the fields and into the rivers straight away when it rains. I was actually out in a field doing a test the other day. I felt like back at school doing geography.
Wonderful. So what are you going to get moving forwards in terms of radio technology? Because I have to admit that's the bit that really gets me excited. I can't get too excited about water, even though I was flooded twice.
Yeah.
But then I moved, so I live on a hill now, so it's much better.
Yeah, I thought that is.
It means I don't have to worry about river levels anymore.
You do have to worry about runoff and urbanisation, so there's still a place for this. But the radio hardware we've kind of outgrown, I think. It's the packet length wasn't big enough to take the device identifier, so we had to make our own device identifiers that were short versions, and then you have to manage them. You have to keep a spreadsheet of numbers that map to device names, and that whole thing becomes quite a mess. So what we did, we took the identifier off one of the pieces of the hardware and used that, and that blew out of the payload size of the packet. We start transmitting two packets. If one of them gets lost, then we have to add some kind of correction so that we know it's got lost. Get more than one device transmitting, they collide. There's no real collision detection because we're not working at that level, and you end up reinventing the wheel. And you think there must be something better than this. Plus, the range is limited. In fact, we've gone backwards in range since we did the latest versions. So,
would you consider using a commercial service like one of the Sigfox network operators?
So that's a big philosophical question, actually. Do you wait for the subscription operator to arrive to provide your infrastructure, or do you build it first?
Or do you do both?
I think you have to do both. If you build your own infrastructure everywhere, at some point you're going to look like a fool having built your own infrastructure, unless you want to become an infrastructure provider. A lot of people say, why don't you use mobile? And there's lots of reasons.
Yes, why don't you use mobile?
It's expensive. As the modules are expensive, there's a subscription charge for it. The power requirements are huge. It has to be on a solar power supply, and the form factor, it just increases.
Well, you know what? I would take it to task on every one of those bullets because it doesn't have to be. So picking those off one at a time, it doesn't have to be expensive, and you don't even need a data service. You can use something like USSD as your transport.
Okay.
Which can be extremely cost effective. And on the power side, you only have to power up your device when you want to send.
And when
so
you
the
want
rest of the
to
time, you leave it asleep because
they're not known for their rapid response mobile networks and devices. They wake up, they take a few minutes, make a coffee, have a think.
Well,
so I think that's interesting. Anyway. So the issue is, if you want 15-minute readings, then how long do you think the maximum, what your duty cycle would be? It would be about, what, 1 in 3?
15 to 20 seconds to power up from a standing start.
Right. So that's...
And if you're static and you're willing to cache the variables, you can get that down to 3 to 5 seconds.
What, the boot time of the device is going to be longer than
that?
Well,
you don't exactly boot it. You just put it into a sleeping state and then just wake it up. So all the registration status is still there, and you just wake it up once every couple of minutes or so when you need to.
I mean, I think that's an interesting interesting set of hardware challenges, which one would have to go down. And then the trouble is that once you've done that, you're in bed with the operator who rolls over and squashes you when you become inconvenient. That's the real. I mean, I don't know if that's Ben's philosophical problem with it, but certainly it would be mine.
Not all operators are evil.
Can I zoom back for a second? I'm curious about something, Ben. This is a lot of information. I assume it's being logged or stored somewhere. maybe there are other uses for it as well as the immediate.
So definitely, yes. One of the products that we do is actually to alert local authorities. So it actually turns into alerts. And the data that we're collecting can then be used historically to calibrate the flood models. And then once you've recalibrated your flood models based on this input data, you can then run the live data through those models and actually get a better idea of what's going to flood. So it helps with calibration and actual prediction. I can show you, a little glimpse of what it looks like around the back. And here's our telemetry coming in. We've got a missed pole there from this one. This one's 7 hours ago it went missing, for example. The battery levels, you can see them being red over time. We've heard from this one recently. You can look at the deep and actually see what's going on. So the raw data is there, and it's all being logged in a time series database.
The one that went missing, does that mean it was stolen?
Pardon?
The one that went missing, was that stolen, or is it just an equipment failure?
It's actually gone missing. So that one appears to be on a Sunday afternoon. Someone on a punt. It was quite a nice day, and someone on a punt went and knocked it off from under the bridge. That's my guess.
A question from IRC that Fred asked, and it's a good question: is 15-minute polling enough to detect a flash flood?
We think so. Yes, I think it depends how flashy you're talking. I mean, the catchment we're in isn't. It is flashy, but not to that degree. You can certainly change the polling cycle. And one of the things we have considered, although not implemented, is to send messages. We only receive messages from the sensors, but you can tell the sensors to start monitoring more rapidly when you expect bad weather, and also more slowly when things are less risky. And you have some good meteorological data to help you make those decisions.
So, on the geeky standpoint, what's the you say that the devices under the bridges talk radio, short range radio to people's broadband, but what's in between? What's your middle box? Do you have a middle box, presumably?
The magic of the Raspberry Pi.
Okay.
So we have an equivalent radio in this device here, which you can see just perched on top, and that receives the frames incoming from the sensors. So you can put several radios out, several sensors out there, and have them collected with one device.
Is that something you do? Do you have like lots of sensors coming into a single device, or are they generally one per one?
Well, it's generally one each, but then I think it's because of the range of the radio that means that we don't do that. But what the one that is at the end of the white space backhaul is actually on a proper antenna, and that covers quite an area. Now we've got something like 6 sensors out there, including under the floor of the pavilion, temperature sensors and other things like that. So yeah, we use a Raspberry Pi in this case because we just we're prototyping first of all, so prototyping on Raspberry Pi is just incredibly easy, and although it's overkill, we can't actually make anything cheaper that does the same job because these things are £15. You can't really make it much cheaper and reliable than that to put an IP stack and do a custom translation.
So basically, all you're doing there is you're not doing any analysis on the Pi. It's just like passing the data through with a slight transform, perhaps.
That's right. What it does, it takes it from over-the-air proprietary radio protocol and puts it into a standard, which is called MQTT, so Message Queue Telemetry Transport. And it's created by IBM some years ago. And you can put anything in those payloads and set the the parameters of the session, so they're either fire once, deliver once and only once, queue them up, or lose them forever. We also have a secret source pairing system, which allows you to only receive data from expected sensors and then have them delivered automatically to the correct topics, to the correct data streams, without any mucking about. As soon as you define the data stream, then that sensor will pick it up. That gateway will pick it up from a particular sensor that's been mapped to.
Another quick question. Do you have any kind of encryption or means of rejecting bogus update?
So the encryption in various stages, we don't have any encryption on the MQTT, but we know that we can easily add that with SSL. The over-the-air encryption on the radio, that we haven't bothered with because we know that it's just a limited experiment. We know that that is something, if you move to LoRaWAN, that's something we would put on straight away. So we've moved from a kind of community experiment into something that now needs that level of protection. You can spoof the readings if you want. You have to be one of the associated sensors. So to do that, you would have to first listen over the air, listen for the IDs that are being used, then pretend to be one, and then send your own. And get one of these radios, of course. Alternatively, you could just go up and put your hand under the sensor. So there are other ways of spoofing it. Yeah, so we know some of the weaknesses. We've certainly done the work on the pairing and the keeping that bit secure. But yeah, at the moment it would have slowed us down, and now we know that that's the next stage that we need to do. And since we're changing the technology, it doesn't really seem like it's a good time to retrofit it.
I want to remind everybody that we're watching on Twitter. That would be the tag VUC565. Of course, we're on IRC, as always. And if anybody on ZipDX has questions, you hit *6 to toggle your mute state, whatever that means.
So
you know what that means.
Have you thought about doing some sort of local... I mean, you're doing local caching, basically, of data, so if they lose the DSL for a little while, the data will presumably turn up a bit later or whatever. But have you thought about doing some local analysis as well, so that you know, maybe even your Raspberry Pi could sound a klaxon if the local monitors are flooding and the DSL is out, or something? So some kind of localized action as well as collection.
Yeah, we aren't doing anything like that. I'll be honest. We did talk about that as a probably more of a thought experiment. We were trying to work out how if you can't do a cell broadcast, I mean, this may not be true anymore, but cell broadcast was always touted as this way of telling people in an area that something bad was going to happen to them. Then if cell broadcast isn't the thing, then you have to, someone said, well, why don't we send them all a text message? Well, you have to know who they are, where they are, what their phone number is, and then whether you're allowed to send them a message. That's quite complicated. That's herding cats kind of territory, I think. How would they be notified now if they don't have a mobile, and you know, the little old lady living in a house is fairly isolated? What would she expect? And she'd probably expect someone to come around and tell her, whether that's a neighbour. So this is word of mouth, and that's partly what this is about, is that it's involving the community so they know. But also a van with a loudspeaker on it might come round. Now, if you can connect a flood warning siren, particularly in places that have very flashy floods, then people know what that siren represents. If you have a siren, it is binary. Something bad that we've told you is going to happen is just about to happen. So it doesn't. It's like the lassie bark. You know, what is it actually telling you? It's telling you one thing. So if you've got that as a major problem and a major issue for you, I think that's where that would fit in. Having a siren on Botley Road, I don't think would do a great deal apart from annoy people. The LED blimp drones, perhaps that would work.
I was actually thinking of something as simple as maybe fitting a screen on the Pi with a little audio thing, so that if you happen to be in the house when it senses the flood is rising, then it could bleep at you, and you could go and read the display and decide whether you're going to go back to bed or get out of the house or move the furniture upstairs or whatever it is.
Well, there are a fair few systems that actually do send an SMS, and that's the equivalent kind of local detection, local action. And I think what we're trying to do is get away from that, because the information is just one of many data points. You want to combine them together first to understand the situation as a whole and whether it's going to get any worse. Now, if you know that the rate of increase is very high, then you know that you haven't got long to think of the answer. But if it's a very slow rate and you cross a threshold, you're going to be pretty annoyed that you've been woken up for something that you knew was almost finished anyway. So I think a little bit more intelligence in it. If we could control them and send the messages back to the devices, then yes. But I don't think having it on the gateway is the right place. I think having your internet connected flood warning light bulb is the answer. And if all goes according to plan with the Internet of Things, that means you can buy that from your people in the hardware shop, or from Philips or something like that.
Right. Okay. Now I'm just interested in whether there's a space for kind of getting away from this business about concentrating all of the data and all of the decision making centrally. I mean, one of the nice things about what you're doing with a community-based project is that it is a community project, and then you start to wonder about whether, if everyone's contributing the data, like maybe it would be nice if some of the actions were also community-based rather than centrally decided. But I mean, that's I'm quibbling basically.
No, I think it's an interesting point, because what is the action expected off this map? If I said to you, Tim, quick, look at the map, what would you do now? Depends where you live, first of all.
Right.
Depends if you know anyone who lives in that area. Should you tell them? What do you do to disseminate that information? See, it's fine now. We're not going to die. But how do you take action right now based on what you see here? And that can feed back into a community response. We have looked at that aspect of it, and there is a danger that you use up all your time becoming the neighbourhood watch of flooding and never make any money. So that's one of the possible avenues to explore. It might be that the data can then be used by someone else to do that part, I think.
Right. So that's another question I hadn't asked, which is, what's the ownership of the data? Is it commercial commons, or
We started with the Oxford Flood Network as open data, and no one seemed to really care. And then we thought, how are we going to make some money out of the Flood Network technology? And selling the data seemed like it was a possibility. Then we realised that we had spoken to at least 5 different hydrologists, and none of them knew how much data was or where it came from. So that was some bad signs that maybe people don't pay for level data. And then I think what we did next was to turn it around and say, well, okay, you will expect this service out of this. If we do a commercial installation for a local authority, then would they open the data that they have paid for? And I think that is a possible model for this, that you pay for the installation as a local authority, then you make that data available as open data. And that's kind of how it works at the moment. It's just that we're approaching it from trying to pull it through from the other side, trying to make open data by installing the hardware,
Right.
and then getting someone else to pay for it. It's quite quite complicated.
Have you talked to farmers at all? Are they interested in this?
No, there are not a lot of farmers in central Oxford, although they are in the floodplain, I must admit. Yeah, there are lots of small use cases like that with individuals who have a particular arrangement they want to monitor.
I'm just thinking that people who are upstream, and as you say, in the, in the whatever the I don't know the terminology for this, but wherever the water is collected, collection zone, if they would they be interested in that? Would give you a couple of hours warning rather than a few minutes because you'd be further upstream.
Yeah, they certainly upstream in the catchment there are things like catchment partnerships, and they will lobby the farmers to maybe change their methods, and so it reduces runoff. They don't have to dump a load more fertilizer on that just got washed off. And I think those are ways that you can affect cycle. As a technology, I don't think we have a good enough case for them. They're interested in whether what they were doing before is still going to happen. Will they get paid for it, or can they get paid to not do it? That's the other thing.
Right. Okay.
With the payment system, so
you always got to look at the money, basically.
Essentially, if I want to keep doing this, I got to look at the money, because the hardware doesn't fund itself. Normanet have covered it up till now, but now we're on our own with the hardware costs, and we have to find a model that supports this. I think that hybrid of commercially installed and also the community network together, I think that might be it.
Cool.
Okay, anybody else have any questions on ZipDX *6 to unmute, or on IRC, or on, if you address them to VoIP users on Twitter? Otherwise, we will repeat the fact that you can go to flood.network. Is that correct?
That's right.
I did not even know there was a .network. That's excellent. It's very easy to remember. I'm sure Andy has a question, though.
Well, I do actually, but mine was slightly different. I was thinking back to the Illinois Institute of Technology and the real-time conference there, and one of the keynote speeches, which was particularly about water levels in the US and how little is actually known about underground water levels. And I was wondering whether this sort of thing could be extended to do well monitoring and other such things, so you could see how much water there were in various aquifers. I've no idea how much data is actually available for that in the UK anyway.
Great question on spin-off technologies.
So I discovered I have a local hydrogeologist. Oxford's a very strange place. He is responsible for all the boreholes around Oxford, and what they do at the moment is they have a data logger in it with a pressure transducer that collects the data during the floods, and when the floods have gone, they can then go and pull them out on a cable, plug them in a USB port, and it takes about 3 days to collect all the data from them. There's definitely an interest from them in putting boreholes live into the flood model. As regards wells, yeah, it's definitely an idea to be able to take people's local use, which is understanding whether they get water in the well, and then combining that together to make a more regional picture of something. So they may not care what the aquifers are like regionally, but they care whether they've got any water in their well. And I think that's what I'm trying to do with the flood network as well, is what's the water level like down the end of the road? No one else cares but me, except when you combine it together with the rest. So you make a local use for it, and that justifies collection for a national use. Benefit of that is you don't always have to put your own sensors in. You collect other people's stranded sensor data and put that together to make a value out of it.
So really, what you're saying is that this data needs to be made available publicly, so that people like yourself can make use of it.
Or we make agreements with the people who have that data and license that data.
Okay, one way or the other.
Yeah.
But if it's a national body, I would hope that open sourcing the data is a much more beneficial way to go.
If they're prepared to pay for it first to be retrieved and aggregated, and then they would open it. Otherwise, without that section in the middle, they'll never get all that data, and we won't get the result of that open data.
Yeah, it's all about money, really, and who owns what.
It's about, yeah. And when we say it's all about money, it's all about actually surviving into next year and still doing this. So I guess yeah.
I think what's interesting about this as an IoT project is that there are, unless I've missed one, there are actually no privacy concerns. It's not like knowing what's in people's fridges.
Well, have you ever tried to get insurance living in a flood area?
Okay. Well, I mean, is that an interesting case? Can you say, here are my water levels? I've reduced my, like having a house alarm. I get reduced insurance prices because I have a burglar alarm. I actually don't, but get reduced prices. But
it is,
in theory, I could.
In this case, you will have dug some ditches or cleared out all the gullies, and consequently, your water levels will be much lower. Therefore, you should qualify for a lower insurance premium, perhaps.
Yeah, I think you could demonstrate that without the technology. That's why I think this approach with the insurers, they're interested in the cost way of recognizing their flood risk and improving their flood risk models. But individually, it's not like accelerometers strapped to a car, and the accelerometers say how fast you've traveled and what you've been doing and how you've been behaving. It's your environment and whether that environment is still within some bounds. If you have enough sensors, yes, it starts to look like that previous model. Otherwise, it's hoping that no one spoofed the sensor readings, I suppose. I think there's a lot of distrust of it because it's a new technology, and there may be ways to assuage those worries from insurers, and that might actually prove to be the best way to go.
All right.
You've got all the other applications that you can use a similar technology for. So, like round here, everybody runs their heating off heating oil tanks, and all of the tanks have got sensors in which measure the oil level, and just being able to watch levels of fuel consumption during the winter could be relatively interesting. Certainly, when your oil level goes below a certain level, you probably want to automatically arrange a resupply run, subject to certain constraints, and you want to be able to put together a community order to make it worthwhile that the big tanker coming out and doing, I don't know, a dozen deliveries all in a very small area all the same sort of time.
Perhaps. That's already being done. Yeah, I met someone who was doing that. I'm not sure if he was taking exactly that angle. I think he had an axe to grind on fuel costs or something, but essentially it was a sensor that would tell you when your fuel was low, and the community would join together to make lower price buying. One of the things I was told about is that some of the deliveries actually can scan the tank levels as they pass by, and if they want to drop some off on the way, they can get rid of a bit of surplus into other people's tanks and charge them as they go.
Now that is useful.
And that means you don't have to go back with a full tank or half a tank.
Yeah, and I would expect you probably get a special price for the opportunity drop.
Yes, I think so, and I think that is one of my favorite things to look for in Internet of Things business models is that supply and demand and what saving you can make. If it's an opportunity for someone else, based on either your misfortune or a condition that will pass.
Well, yeah, in fact, on that strand, you could also do a fuel tank burglar alarm. So if somebody comes along and suddenly starts siphoning off your fuel, and all of a sudden the oil level drops dramatically, you can alert PC Pete to come out on his bicycle and apprehend the person who's attacking your fuel tank.
You can, or you could have it ignite.
Well, I wouldn't want to do that really, but well, yeah, you could
Actually,
deploy...
James, you would want to do that, but knowing you,
Well,
but there you go.
no, we just deploy Andy's sentry bot.
Which has suddenly become a flamethrower.
Well, it could be, couldn't it?
This sounds like a good time to go to the mature audiences only version. So we'll ask one more time for questions and remind people that they can check out flood.network. Great URL. Wow.
I think I just want to amplify that thing that Ben
Sure.
just said, which is that there is, I think that's the most interesting business model for Internet of Things, is the peak shaving, the opportunity to shave off peaks in demand by moving demand around slightly to make it significantly cheaper to deliver. I think that is the biggest and most interesting opportunity, and everything else is way down the line commercially, and certainly Bluetooth toothbrushes are way down the line as far as I'm concerned.
Definitely.
Okay. Ben, it was great to have you. Thank you. And of course, anything new you want to talk about, you ping us and come on back. You're always welcome.
Thanks for having me. It's been fun.
And thanks to Tim for thinking this up, and thanks to everybody who participates. We're just in a moment, we're going to go to, actually I shouldn't cut off to the mature audiences because we've got Alan Quayle is with us. Let's talk for a second about what's going on with the TAD Hack and TAD Summit, because I will be at least one of those, maybe two.
Hey, I hope both, Randy. So thanks so much for giving me a little time just to give it a quick update on what's happening with TAD Summit. So TAD Summit is on the 17th and 18th of November in Lisbon, but it's not just those 2 days. We've got a ton of stuff happening around it. On the 16th, well, actually on the 15th and 16th, the Cloud Communications Alliance are having a big meetup there. Then we've got on the 16th, the Monday, workshops from Le Bon, a benchmarking workshop across telcos. We have a RESTCOM workshop for newbies. And of course, we have the Oracle workshop where James will be presenting. So we're looking forward to that. Then after TAD Summit, we've got a Huawei workshop, and the Telestacks guys have got a 3-day, or potentially 4-day, marathon RESTCon event. So this is whole of the telecom app development community are coming together in and around Lisbon for the whole week, from basically the Sunday through to the Sunday. So it's going to be great fun. And just a little bit of background, TAD Summit is all about the business of telecom app development, while TAD Hack is all about developers, creativity, and doing cool stuff. And as you said, Randy, we also have TAD Hack coming up in Paris on the 12th and 13th, and we're hoping we'll be having Randy play there. It's taken way too long to get that confirmed, but hopefully in the next couple of days we'll get that confirmed. So really looking forward to it. It's going to be a really cool, mellow hackathon with a great Parisian feel. So,
and I'm very difficult on the contract, though.
Oh, tell me about it.
Yeah, what color M&Ms does he want? That's what we need to know.
Yeah. No, it's more than no green light on the stage.
That's right.
M&M, right?
Exactly. And we're going to be updating the agenda later today. I mean, if you just go to tadsummit.com, click on events, you'll see the agenda, download it. I mean, it's jam-packed. And I think the big shift this year is we've been talking about this, the democratization of telecoms, thanks to the internet, thanks to open source, thanks to telecoms just being programmable through all the APIs and platforms that are being made available. But we're really seeing now lots of small, medium businesses making real money. I mean, that for me, I think, and the presentations we're going to have, the bias is definitely outside of telcos and showing just businesses focused on IoT, focused on financial services, using telecom capabilities and making real money. So I think we're moving from this, there's the vision, the vision may happen sometime, to we're really starting to see big bucks being created. And just to share with you, I was at the Flowroot customer event in Seattle yesterday, and again, it was just heartwarming to see some of the businesses that Weave. They're doing amazing business in just delivering to doctors, just a vertical, a integrated sort of ICT solution, embedding communications and messaging capabilities into just dentists actually processes, and they're taking that and they're now applying it to optometrists, and they're doing amazing business. So we're really starting to move from what is a cottage industry, I think, to really becoming a significant trend in the market with this whole concept of democratization of telecoms. So that's it. Just a quick update. Be there or be square. It's going to be a couple of hundred people having lots of fun in Lisbon on the 17th and 18th of November.
And let me just go out on this note before we go to the mature audiences only version of the VUC. A lot of these events, you have a chance to meet with and speak to a lot of interesting people. I won't even include myself in interesting people, but you've got James, you've got Andy, you've got all the people that you see here who are regulars. I don't know if Tim is coming, but he's often at some of these. Tim, are you coming to any of these? Do we know?
I'm going to try and get to Paris. The Lisbon is too businessy for me. The kind of stupidity I get involved in is not going to happen there.
Okay. Well, we always have Paris, right, as they say. Anyway, thanks everybody for joining us, and thank you Ben Ward for joining us, and we hope to see you again soon.
Thank you.
Okay, so Flood.network, and we will be back next week with a fantastic, I'm told it's going to be a cage match. I'll reveal more next week. Okay? Later. Oh, wait a minute. Let me fade to the topic before we go out on YouTube. Okay, that's professional. That's Michael's work. Good night, everybody. Good night, Mrs. Donovan, or whatever that name is. And we will be continuing with the mature audiences only version without Debbie, because she can't make it, in a moment. Later.